Okay, we'll work through an example here that's going to find the mean and standard deviation of the random variable x. Now this random variable x is the number of heads obtained when tossing a coin 3 times. Just bear in mind that tossing a coin 3 times is the same as tossing 3 coins all at once. We count the number of heads and work out the probabilities. So one of the really neat ways of doing this is to actually draw up a table. Now the table eventually will have probably around about 6 columns. So we'll just do the first 3 columns. And in the first column we're going to have all the values that xi can take. Now xi are all the values that the random variable x being the number of heads. So if we're tossing a coin 3 times, we can have 0 heads. So this would be like little x 0 is equal to that. Little x1 would be equal to 1 head, 2 heads and 3 heads. So they are all the different values that xi can take, 0, 1, 2 and 3 heads. Our next column, we've got the probability that capital X equals xi. Now, from previous work, and you can use tree diagrams and draw up a table of the probability distribution, we know that the chance of getting 0 heads is 1 on 8, 1 head is 3 on 8, 2 heads is 3 on 8, and 3 heads is 1 on 8. And as a general check, you should always add that column up and make sure that we get to 1, and indeed it does. Now from our rule, we know that the mean of a distribution, which we denote by x bar, is equal to the summation of xi p capital X equals xi. So there is a multiplication between those two. Now xi we've got is this column. So now we're going to actually, we've got px equals xi, which is this column. So we're actually just going to make our third column xi times that. So this will be xi times px equals xi. Then we've got to add them up. So we're going to multiply the first column, which is xi, times px equals, which is this column. So 0 times 1/8 is 0, 1 times 3/8 is 3/8, 2 times 3/8 is 6/8, and 3 times 1/8 is 3/8. So the summation means we've got to add up this column. So we've got 0 plus 3 on 8 plus 6 on 8 plus 3 on 8. And we get 3 and 6 is 9 and 3 is 12, 12 on 8, which is 3 on 2. Now what is the mean? The mean, this is not a probability. The mean is what's the average as a loose term, what is the average number of heads that we can expect tossing a coin 3 times? Well, I think it stands to reason that it's around about in the middle, so 3/2. So that's the mean. Now to do the standard deviation we need to add some more columns. The variance, before we can work out the standard deviation, we've got to work out the variance. And as covered in the previous lecture, it is equal to the summation of xi minus x bar squared times probability x equals xi. Okay, we go back up to our table. We've got probability x equals xi, that's that column there, so we've got that. But we haven't got x minus x bar squared. We've got x bar now, which is 3 on 2. So our next column will be x minus x bar, xi minus x bar. So we have got to get what's in the first column, that value, and take x bar 3 on 2 away. So 0 minus 3 on 2 is negative 3 on 2. 1 minus 3 on 2 is negative 1 on 2. 2 minus 3 on 2 is equal to a half. And 3 minus 3 on 2 is 3 on 2, 1.5, or 3 on 2. Once again, this should always add up to 0. If x bar is in the middle, when you take it away, you should get 0. That's the meaning of x bar, the fact that it is in the middle. So the summation of this should be equal to 0 always. Our formula down here for variance means we've got to square this one here. So that's our next column. So xi minus x bar squared. So all we've got to do here is square the values that are in here. So the square, when we square a negative, we're going to get a positive. Square the numerator, square the denominator, so we get 9 on 4. Square a negative, we should get 1 on 4, 1 on 4, and 9 on 4. Okay, now one thing to look for in here for correct calculations, the fact that all these values have always got to be positive because we're always squaring. So if you get negatives here, we're always going to have positives there. To help us calculate the variance, we need to, have got a value here that we're going to multiply by the value that's in this column here. So we've got that column multiplied by that column. So up here we're going to write xi minus x bar squared, which is that one, times px equals xi. Okay, so I've got to multiply that value by that value. So we've got 9 times 1, we multiply the numerators, 9 times 1 is 9, 4 times 8, 32, 1 times 3, 4 times 8, 1 times 3, 4 times 8, 9 times 1, and 4 times 8, 32. So the variance, now the summation means we've got to add those values up. So we'll just write them down. 9 on 32 plus 3 on 32 plus 3 on 32 plus 9 on 32. That will be equal to, so those values there I've just written down. You could add them up underneath here if you like and just add them up. So all the denominators are the same, so we can put down 32. And when the denominators are the same, we simply add the numerators. 9 3 is 12, and we get another 12 there, that's 24. Always cancel down. We can see straight away that 8's going to go into the top and bottom, so 3 and 4. So that's the variance. The standard deviation, which we'll abbreviate to SD, is equal to the square root of the variance, and that's equal to the square root of 3 on 4, which is equal to a little bit of surd work here, root 3 over root 4, just find the square root of top and bottom, so that's root 3 on 2. Okay, so it's got a standard deviation. This is a measure of the spread of the number of heads, 0, 1, 2, 3. So it's a measure of how much those values are spread out. The mean is a measure of the centralness or the middle, so it's 3 on 2. So that shows you how those two formulas work, the formulae work. The summation xi times p x equals xi, and the variance formula as well.